Hello and welcome back to another medium problem. I think I've solved this one before. Let's see when. Oh, actually this month. Okay, cool. So I should be able to do this again. So yeah, this is about copying a linked list with random pointer. And let me just read the problem description so we all know what's going on. A linked list of length n is given, such that each node contains an additional random pointer which could point to any node in the list or to null. Construct a deep copy of a list. The deep copy should consist of exactly n brand new nodes, where each new node has its value set to the value of the corresponding original node. Both next and random pointer of the new nodes should point to the new nodes in the copied list, such that the pointers in the original list and copied list represent the same list state. None of the pointers in the new list should point to nodes in the original list. For example, if there are two nodes x and y in the original list where x dot random pointer points to y, then for the corresponding two nodes x and y in the copied list, x, the random pointer of x should point to the node y, to the copied node. Return the head of the copied linked list. The linked list is represented in the input-output as a list of n nodes. Each node is represented as a pair of value and random index, where val represents the integer that can be accessed through node.val. So this would be our node class, and .val is that property. Random index is the index of the node in the range from 0 to n minus 1. So I guess the nodes are enumerated. That the random pointer points to, or null if it does not point to any node. So let's see. So next is actually, wait a second. The next points to a node, right? It doesn't point to the value of a node. Or does it just have an index? Yeah, why would it just, well, it can't just be the index number, right? Otherwise it doesn't make any sense. So the random pointer is actually pointing to a node object. Otherwise we just have to copy the y value, right? Which is pointless. We want to do a deep copy. Okay, cool. Your code will only be given the head of the original list. Here, so we see that here. Okay, nice. Constraints, okay, there's a limit on the number of nodes. We could receive no nodes. We could receive none node. And then the values are arbitrary, but within a range. Let me see. The index of the node range from 0 that the random pointer points to. So that part I don't get. So this random index, so here it looks like it's a pointer to a node object. Here it says it's an index. Oh, it just says the linked list represent. I guess this is again for understanding the test cases, right? Yeah. So this is for understanding the test cases. So the value is this, and then the random index either null or points to null. Here, this means it points to the first node. This 4 points to 0, 1, 2, 3, 4 to the last node. Okay, I get it now. Right, so here's an example. And we see the linked list, and then on the bottom we see the random indices that point this one to null, this one to the first node, etc. Okay, I think we have a good understanding of how that works now. Yes, so I think, well, obviously, since we're giving the head of the list, we will need to traverse through the entire list. And I see that we could do a 2-pass through the entire list. And on the first pass, we create all of the nodes. And in the second pass, we could update the random pointers in our copied list. That would be one approach, would be linear time and linear space, since we need to copy all of the node, or we need to clone each individual node. So Yeah, I don't think we can do better than O of n time and O of n space, because there's nothing else that we know about those nodes of how we could well, yeah, I mean, we have to store them anyway, so that's going to be O of n time and O of n space, time and space. And let me just think for a second, is there another way we could solve this instead of just doing a 2-pass? There's probably another smart way, but maybe that's an optimization to look into later, but it wouldn't change the runtime. So let's just implement the first idea that I just had. And yeah, go with that. So we're giving the head of the list. So I'm just gonna store a reference to the head. Oh, well. No, we're going to iterate through the list with a node variable. And in the beginning, it points to head. And the clone, well, first of all, the easiest thing is to just take care of the edge case. So if not head, return none, right? It could be that we don't get any elements. So in that case, we're just returning none. Okay, now, so if we wanted to iterate over the list, we would do the following. While node. And then node, and then here we do something. We clone the node, and then we advance the node variable to the next element in the list. That's how we iterate through the entire list. So we would say clone. If we want to clone the node, clone equals node. And we're going to initialize with the same integer value as our current node. Node.val. The next is going to be, well, we don't know what it is yet because it doesn't exist yet. And random is also going to be none because we don't know what random is right now. We should probably remember what the previous node was, so that when we create the first node, we don't know what the next one is. But then when we iterate one more step, we create the next node, and now we should update the pointer of your previous cloned node that points to the next one to a new cloned node. So we're going to track the previous node in our original list, like so. And I think we can also do it like this. Yes. I think that should work. I think those two expressions are evaluated before those two are assigned, if I'm not mistaken. Otherwise, we would, if this one was assigned to node, and then it is read again, and then assigned to brief, then we finish it. But I don't think we do. Yes. And what we also need to be able to do is we need to be able to look up the cloned node given an original node from the original list. So we need a data structure that indexes all of our clones. And we're just going to do this. And what we do now is we're just going to put into the index, we're going to put the clone. That's what we will do. And yes, that's what we would do. Now, to update the next pointer of the previous clone, what we would have to do, we would have to look up, well, we would have to look up the previous node. And we would have to take that one and point it to clone. That's pretty much how we, so this one is the previous node of the original list. This expression is the previously cloned node. So it's a clone of pref. We get that by getting index of a pref. And of that clone, we set the next pointer to our latest clone. That's how we do that. All right, so this would be the first pass. And now, because some of the nodes might have might not have been created yet, what we can do is we for example, if we're here and we're cloning this node, we cannot set random yet because if the random was pointing to the end, that node doesn't exist yet. So that's why we need the second pass now. And we'll do the exact same thing as we did before. We iterate over the same list. This time we only need the node. And yeah, we are going to get the clone. No, wait, first we're going to get node.random. So that points us to the thing. And if we get the index of of node.random, that means we're getting the node that our random list node should point to. So index node.random equals that. And then we just advance our node pointer. So I hope that wasn't too fast. But you should be able to see quickly how this works. So index node gives us the cloned version of node. This sets the random pointer of the cloned version of node to the clone of the node that is referred to. Oops. What's happening here? This gives us the node in the original list that we refer to. It could be none, which we should take care of as well. And we're going to get the clone of that. So if node.random is not none, then we do that. Otherwise, we'll leave it as it is. Right, and so now at the end, we just return the head of our new list, and that is simply index head. So that's that. I think that's everything. Just checking real quick if I see any obvious errors. No, this is fine. This is the second part. Then we're advancing node so we don't get an infinite loop. Yeah, and then we return the head of the cloned list like so. Yeah, let's run the tests, see if I missed any errors. And I did. Let's see. Index.pref.next equals. Aha, yeah, in the first iteration, pref is none, right? So we have to take care of that case as well if pref. Otherwise, we can't really do that. We don't have a predecessor element, so we can't set the successor of a non-existent predecessor. All right, so that looks good. I'm just going to submit this, see if all test cases pass. And they all seem to pass, which is nice. Let me just think real quick about if we could do this in one pass. I suppose we could. But what we would have to do then is we would have to check if the random node has already been cloned or not. If it has already been cloned, then it's easy peasy. We can just refer to it. And if it hasn't been cloned, we need to create the clone first before we can refer to it. Yeah, maybe let's try this approach. Let's try that. Let's try to get that to work. So here we're automatically cloning the node. But we should really check, does the clone exist? If node in index, well, if the node is not in the index, we have to create the clone. Else, clone is already in the index and we're just going to get it out. Node, right. So in case we've created a node before, then we're just going to fetch it out. Otherwise, we need to clone that node. Okay, so now, yes, and here we set that clone. Yes, and here we set that clone. Good. Now, if we have a previous predecessor, then we still have that logic. But now we need to take care of the random pointer, right? If node.random, it means our current node from the original list has a random pointer. In that case, we need to check if node.random is in our index. And if it is, right, then we could simply say clone.random equals, oh, well, exactly that node, right? Done. If that is not the case, then what we'd have to do, we would have to clone that random node. So we would write it index node.random equals, and that would be the node.random value and none. So we create that node and it's not linked to anything, but it has the correct value already. And we can simplify that a little bit. Right. So if it doesn't exist, we write it and then we just set the pointer. Right. Okay, so, and when we then continue to iterate, you know, if we created a node already, we iterate through our list and we go here, and then this node has already been created when we were here at the random. So this already exists. So we just get the clone and we use it to update the pointer of the previous to the already cloned node. And yeah, that's then good. So I think that should work. Let's run it. Let's see. Okay, that looks good. Let's submit it. All right, there you go. Yeah. So that's a one pass off and time and off and space solution. I think that's easy enough. So yeah, why don't you try to implement this maybe in both ways? Remember to start with the way that is the easiest. Don't optimize anything unless you really have to. And yeah, enjoy.